in this lesson, we're going to be looking at the geometric sequence. Unlike the arithmetic sequence, this one doesn't have a constant difference but has a constant ratio. We'll start by looking at its general term and seeing how we can break it down to check what component means what, so that we can move further on with some couple of examples. Okay, so the general term looks like this. Tn is ar n minus 1 is equal, so this is the general term where the a, like the arithmetic sequence, is the first term and r is the constant ratio. Now the constant ratio has a formula: Tn over Tn minus 1 is equal to Tn minus 1 over Tn minus 2. So this is how you would check for the ratio, the constant ratio for any geometric sequence. Interesting to note that the geometric sequence is also known as the exponential sequence. Without any surprise, you will find that we will use some exponential laws to decipher some of the problems. So let's start by demonstrating with an example. I'm going to take the following sequence: 2, 8, 32, and then it continues until wherever. Now we're supposed to determine the general term for this, so determine the general term for sequence. Whereas in the arithmetic sequence we started by determining the constant difference, here we're going to use the formula for the constant ratio to determine the r. So we'll take term 2, r equals T3 over T2, which is also equal to T2 over T1. If these ratios are not equal, then this is not a geometric sequence, it's something else. I don't know what, but it's definitely not a geometric sequence. T3 would be 32 over 8, and we want to know if the proportion is equal to 8 over 2. This is 4 and this is also 4, so the constant ratio r is 4, right? So how we would determine the general term for this, we would say Tn equals ar n minus 1, the first term being, what's the first term? 2 times 4 n minus 1, and that's essentially how you would determine this. And if you have to simplify it using the exponential laws, just say 2n minus 2, and this would be 1 plus 2n minus 2, and this would be 2n minus 1. So the general term for this given sequence would be 2 to the power 2n minus 1. We just use the law of exponents to, turn this 4 into 2 squared, and then it was n minus 1. So this essentially just expanded into that and gave you 2n minus 2. And 2 is this, we also use the exponent law that 2 to the power 1 is 2, as you can see here, and then because the bases are the same, you add the exponents, and that's essentially what we did there. In the next video, we'll be tackling couple of examples that have to do with determining the nth term that have to do with determining the position of the value, and perhaps determining how to calculate for the constant ratio in places where it may not be so obvious. Thank you.